Again, welcome to Java Programming Language. This is Unit 2, Lecture number 3. Our main objective is to explore the Java numeric primitive data types. We are going to talk about the byte, short, int, long, float, and double. This again, Java primitive data type numeric. Also, we are going to learn how to perform arithmetic operations in Java, which is addition, subtraction, multiplication, division, and modulus operator. Normally, the modulus operator is if you divide two values, the remainder. So sometimes we call it a remainder operator. So we start with the exponent operations. Now here we can use the power function. So for example, math.pow, which is the power function, it takes two arguments. The first will be the base and the second will be the exponent. So power 2 and 3 means 2 to the power 3. And normally if we print this, our answer will be 8.0. So again, in Java, we have the math is a class. And also it consists of so many mathematical functions such as trigonometry, sine, cosine, square root, absolute values, etc. Now, the next one also, we have the math.power 4 and 0.5. Instead of using a square root, as we all know, square root means the exponent is half. So we can use 4 and 0.5, which will give a square root of 4 is 2. And also we can use the math.sqrt and square root 4. The square root function takes only one argument, the value, and also that will return 4. Also, we have the math.pow 2.5 raised to the power 2, which is 2.5 squared, and that gives us 6.25. We also have 2.5 raised to the power negative 2, so that will give us 0.16. Next is the double and float. Now, the difference between the two is the number of decimal places. So a double and float are decimal values. And normally the float have 7 positions, which we say 7 digits, the 7 decimal places. And the double have 16 decimal places. So here we say the double type also is a primitive type. The double type values are more accurate than the float type. So for example, if I have 1.0 divided by 3.0, if again it's a double to give me 16 digits, decimal places. Or in a float, it will give me 7 decimal places. And we can see the last digit is 4. So again, in Java, the int and long are the whole numbers. Float and double are the decimal values. That's the numeric. Also, we have the byte. We also have short. These are all integer, all numbers. So arithmetic expression. In Java, we use the plus is the same as plus, but instead of in college algebra, we write 4x means 4 times x, but computer doesn't know 4x. We have to, again, specify the arithmetic operator. So it's the same as saying 4 plus 3 plus 4 times x divided by 5, then 10 times y minus 5 times a plus b plus c divided by x, which is all the value here divided by x. Then 9 times 4 divided by x plus 9 plus x divided by y. And again, we shall go through the arithmetic operators. Now, how to evaluate an expression is the same as basic arithmetic, the order of precedence. So for example, parentheses come first, exponent, multiplication, division, then addition, subtraction. So if we have this expression, the first is the, again, parentheses. So after parentheses, then from left to right, multiplication and division. So from left, we have our first multiplication, 4 times 4. Then we have our second multiplication, 5 times 7. Then we have addition, subtraction. So we start from left again, addition, then another addition, then subtraction. So the order of operations or the operators is the same as basic arithmetic operation. Parentheses, first, if we have exponent, then exponent will be second, before multiplication, division from left to right, and addition, subtraction from left to right. So we have a program here, and our problem is to convert a temperature. So for example, we can convert a Fahrenheit to Celsius. So we are going to ask the user to enter a degree in Fahrenheit, and we are going to use the formula here to convert it. Now, Java representation of this formula is 5.0 divided by 9, and we know parentheses 2 with nothing means multiplication. So we have multiplied by the variable content minus 32. So let's see the code. Let's see if we can zoom it. So this is our code, and the main goal of this code here is to get an input from a user. The input will be a degree in Fahrenheit. Then we are going to convert it to Celsius. So this program is only doing input, process, output. We are going to execute in sequential order or in linear. So first we have our scanner class imported because we want to use the system.in to get the input from a keyboard. So our main class name is Fahrenheit to Celsius. And we have our main method. Then inside the main method, the first thing we did is to create the scanner object, and we name it input. So again, the scanner object name can be any name as far as we follow the naming rules for Java identifiers. So we have the scanner object now, we name it input. Now next we ask the user to enter the degree in Fahrenheit. And we use the next double because the value we are going to enter will be in decimal. So we can see the variable name is Fahrenheit, the data type also is double. So we use input.next double. So now we have our input in Fahrenheit. We can use the formula now. So we declare variable Celsius where we are going to put our answer. Then we say 5.0 divided by 9 times Fahrenheit minus 32. And then we print our result. We say the Fahrenheit, whatever the user enter is Celsius in Celsius. So this means, for example, if the user enter 0, then it will be 5.0 divided by 9 times negative 32. So the answer will be negative, whatever we get, and that will be the degree in Celsius. So again, first we get our input, then we do our process, then we display our results. So next also we have a program that displays the current time. That's using the system.currentTime mils. And we can see this program here. So here also we have our main class. The main class name is show current time. Then we have our main method. Now we declare variable name total milliseconds. We are using this function. This will give us the current time of our computer system in milliseconds. So system.currentTime mils function will return the current time, and we are going to store it in the total milliseconds. Next, we want to obtain the total seconds since midnight, January 1st, 1970. So we have the total milliseconds divided by 1000. We store it in the total seconds. Then we compute the current second in the minutes, also in the hour. So total seconds modulo 60 will give us the current seconds that is left. Then we divide the total seconds by 60 so that we get total minutes. Then we get the remainder now. So total minutes modulus 60 we give us the remaining seconds or the minutes that is left. So we compute the current minute in the hour. Then next we obtain the total hours now. So we divide the total minutes by 60, and that will give us possible total hours. Then we need to compute the current hour. So total hours modulus 24, because we know the whole day, 24 hours. Then next we display our results. The goal here is how to use the modulus operator. So the main reason why we are doing this is that we are saying that if we divide total seconds by 60, we need the remaining. So the remainder operator we use to store in the current second. Then here we say total second divided by 60. This means actually we want the total minutes. So we know that again 60 seconds represent a minute. So total seconds divided by 60 will give me total minutes. Now, if I say total minutes modulus 60, it means when I divide the total seconds by 60, what is the remainder value? There's a possibility we can have a remainder from 0 to 59. So we put that remainder in the variable name current minute. Then we need the total hours. So we have to divide the total minutes by 60. Then we see the remainder. So total hours modulus 24 will give us the current hour that will remain if we divide total hours by 24. So this is again our arithmetic operations. This is the augmented assignment operators, sometimes called the compound operators. So plus equal, example here means if I say I plus equal to 8, it means I'm going to add the current I value into 8 and I'll assign it back to I. So it's the same as saying I equal to I plus 8. I minus equal 8 means I equal to I minus 8. So I'm going to subtract 8 from I. Then the new result I will assign to I. So for example, instead of writing I divide equal to 8, is the same as saying I equal to I divided by 8. We also have the increment and decrement operators. So for example, if you say plus plus var, this is called a pre-increment, which means we are going to increment the variable first before we do something. So that's what we say, increment var by 1 and use that new var value in the statement. So again, increment and decrement operator either increase by 1 or decrease by 1. So if we say minus var, it means we are going to decrease the value in the variable var by 1 before we do our operation. Or if we say var minus, it means we are going to do something with the variable var. When we finish and we get our result, we decrease it by 1. Or var plus means post increment. Do something with the variable var. When you finish, you increment by 1. So that's the concept here also. And also we use the increment and decrement in the loops. So for example, here we declare variable I, we assign 10 to it, and then we say 10 times I plus plus. Here we say I plus plus. So this means I'm going to multiply 10 by the value of I, then before we do the increment. This is called post increment. So this is what we are saying here. This means 10 times I. When you finish, then you increment I by 1. Or if we say plus plus I means increment I by 1 first. The answer you get before you multiply by 10. So there's a difference between I plus plus and plus plus I. Again, I plus plus means post increment. Do something with I. In this case, I'm going to multiply 10 times I, then I'll increment I by 1. Now, pre-increment means increment I by 1 first, then multiply by 10. Now here we say using the increment and decrement operators makes expression short, but it also makes them complex and difficult to read. So at any possible, we should try to avoid using these operators in expressions that modify multiple variables or the same variable for multiple times, such as this: k equal to I plus I plus I. We also have the assignment expressions and assignment statement. We know, again, this is our increment and decrement operators, that is pre and post. So prior to Java 2, all the expression can be used as a statement. But again, since Java 2, only the following types of expressions can be statements. So we have a variable operator equal expression, where OP can be any arithmetic operators. We also have the numeric data conventions. So let's consider the following. We have a byte, I equal to 100. Then we have long K, I times 3 plus 4. Then double D is I times 3.1 plus K divided by 2. Now we can cast or convert our data type. And these are the conversion rules. Here they say when we are performing a binary operation involving two operands of different types, Java automatically convert the operand based on the following rules. And what this means is that, for example, if I multiply a decimal value with a whole number, the answer will be decimal, because decimal have higher precedency than a whole number. So these are the rules. This is a built-in rules for the system. So if one of the operands is double, the other is converted into double also. So our final solution will be double. Otherwise, if one of the operands is float, the other also is converted into float. If one of the operands is long, the other is converted into long. Or otherwise, both operands are converted into int. So this is how we do the typecasting. In typecasting in Java means changing the data type. We have two types of casting: the implicit casting and also explicit casting. So for example, here we have double equal to, double D is 3. We assign 3 to a variable named D. Data type is double. This will be called type whitening, because since it's double and we assign 3, we can see that the decimal places is not really, it's irrelevant, which means we gain more. Now with narrow, we're going to lose. So for example, I have a decimal value 3.0, and when I convert it to int, I lose the decimal places. The next is 3.9. If I convert it to int, I also lose. So that's why we call type narrow. And this normally happens explicit casting. You have to do this yourself. Now, implicit casting system is built in. I have a variable D double, data type double. I assign 3 to it. And so it's going to add 3.0 or 00, etc. Now here they say what is wrong. We have 5 divided by 2.0. Now, here what we know is that what is wrong is the data type for X. Because as we said about the rule, this is implicit casting. 5 divided by 2.0, the final solution will be decimal value, or float or double. It won't be int. So we have to change the data type for X. Also, we can see how the range increases. The smallest is byte, then we have short, int, long, float, and double. Now let's see the next problem. Keep it 2 digits after decimal points. So our program here again, we import our scanner class because we want to create a scanner input object. Now we are going to ask the user to enter purchase amount. The user use the input object scanner class. with next double because data type is double. So we input the decimal value. Then we find the tax. Tax will be the purchase amount times 6% or 0.06. Then here we want to print the result. We say the sales tax is, instead of 0.06, we convert it to int. So first of all, we say the tax 0.06, the tax, whatever the amount is here, the 0.06 is the tax rate. So multiply that by the purchase amount, that will give you the tax amount. So whatever the tax amount is, we multiply by 100 and we convert it to int. Multiply by 100 divided by 100, convert it to int. So casting in an augmented expression, here, for example, we say in Java, an augmented expression of the form x1 with the operator equal to s2 is implemented as following. S1 equal to t, which is S1, operator S2. T now is the type for X1 implicit, changing the data type. Therefore, the following code is correct. We have int sum initialized to 0, and we say sum plus equal to 4.5. This is okay. Sum becomes 4 after this statement. So that will be the conclusion of our lectures. And again, see you in the next lectures, which will be unit 2-4. Thank you.